This is your pre-lab assignment for your conservation of mass lab. So in this lab here, we've got a couple different things we're going to be working on. We are going to be coming back here to being able to effectively collect data from a real world experiment, to set up an accurate data table, and to graph your data. So we're coming back to some graphing here. We haven't seen this since quarter 1, so we'll see what you remember. You are going to be going back and referencing your graphing checklist. We'll talk more about that here in a second. But then we really are going to be looking again at this law of conservation of mass and identifying when we see a reaction taking place, it is a physical change or a chemical change, and are we actually seeing this law of conservation of mass being followed? Okay. So just as some background here, we are going to be using something called a dry ice. You have seen this already this year when we were doing our Halloween demos, but just as a quick refresher, dry ice is made out of a solid carbon dioxide. So the carbon dioxide in the atmosphere around us is obviously in the gas form. Dry ice is the solid form, so in that solid state. The change of state that it goes through is called sublimation. So sublimation means going directly from a solid to a gas. So that's what you're going to be seeing happening here today. The essential question really for this lab is coming back to this question: what happens to things when they seem to disappear into nothing? You guys know this law of conservation of mass states that matter cannot be created or destroyed. So it cannot disappear into nothing. It can't be destroyed. So what is actually happening? That's what we're kind of getting into here today. The chemical equation that you are going to see take place in our lab today is below. So we have CO2, carbon dioxide, plus H2O, water, yields carbon dioxide plus water. So hopefully this is already making your brain kind of twirl here. What are we going to see? Is this going to be a chemical change or a physical change? You're going to have an analysis question at the end that will come back to this concept, but hopefully some of you guys are already starting to kind of process through that. Thinking about kind of what you just said there, what are 3 things you notice about this chemical equation? You will be starting here tomorrow. Okay, you guys are going to get this booklet out from your teacher tomorrow. You will be starting identifying what do you just notice about this chemical equation that we're going to be observing in this lab today, and you'll be identifying what are the 3 different elements that will be present in this lab. Okay. When you guys are here tomorrow and we're getting started, the lab supplies you guys will see in your bin. You are going to have a glass beaker, a stopwatch, a digital scale, a 100 milliliter graduated cylinder, and you'll have goggles either in your bin or on your table. You will be coming up to collect dry ice at some point in time throughout the lab. So let's go ahead and take a look at our bin of materials so you know exactly what you're going to see. So again, you will have this beautiful beaker here. See if I can use my terminology correctly. You will have this beautiful 100 milliliter graduated cylinder. You will have a digital scale. All of these things are things you've used many times, so you should be familiar with. The only thing that is kind of new here is your stopwatches. We have not used these this year, I don't think. When you guys are going through this, I'll show you exactly how to make this work. There is an on-off switch on the side. So if it's not turning on when you hit buttons, if nothing happens, there's this on-off switch on the side. I appreciate when you are turning them back in that you make sure that there's nothing lit up on the screen. You go back again and you turn that off switch back on. So we see nothing on that screen, okay? But I'll talk more about stopwatch when we get there in your lab procedure and how you're going to use the stopwatch. But this is what you'll see. Again, a pretty easy lab setup for us today. Again, some of the new vocab you guys are seeing here is reactants and products. We'll talk more about this again before you guys get into your lab tomorrow. So your teacher will discuss this just a little bit more, looking at the ingredients we start with before a reaction as our reactants and the end result of our reaction as our products. Okay. In order to make this a 4-page booklet, we made your lab procedure a class copy. So that is the only thing you guys should have in front of you here today as we are going through this. So the main purpose of today, I'm going to walk through this lab procedure with you and make sure you know exactly what you need to do so we can come in tomorrow and get straight into our lab and you guys hopefully have time to finish everything up. Okay. So the first step in your lab procedure, you are turning on your digital scale, making sure that it reads 0. If it doesn't, push that on 0 off button again. So when you have your digital scale in front of you, again, we will turn it on. Please, again, make sure you are pressing on when it is down on your table and not when it's in your hand. Otherwise, it will get a funky reading there. Okay, the next thing that you're going to do here is place your empty glass beaker on this digital scale and push that on 0 off button again. It is going to bring the mass of your scale back to 0, and this is going to really negate or get rid of the mass of that beaker. We don't want that as part of what we're calculating. This is a really easy way to do this without having to do any of the math we've made you do in past labs. Okay, so when you put your beaker on this digital scale, You'll see a number pop up. Let me push this up so you can see. You guys see that number pop up here. Again, what you're going to do once you put that beaker on, you are going to press a button here. This one says 0 or tare. Those are the two words that you would be looking for, again, depending on the type of scale you have. When you press that button, even though that glass beaker is on there, it should take the mass of your scale back to 0. When we pick up your beaker now, it's going to go into the negatives, and that is totally fine. Okay, that is really, again, saying that we are just ignoring the mass of this beaker when it's on the scale. So when we are measuring mass, we're only going to be looking at the ingredients that we have in this lab experiment. Okay, that is actually the next thing, the next step that you see here. Let me move this down a little bit. You are going to remove that beaker from your scale and bring it up to your teacher when you are ready for your dry ice. Again, remember your scale is going to go into the negatives when you take that beaker off the scale, and that is totally fine. Please don't change anything. It should stay in the negatives until you put the beaker back on. A really important safety note here in this step, when you are carrying your beaker, please make sure you are carrying it from this top rim. Okay, let me zoom out a little bit so you can see that better. Please make sure you're carrying it from this top rim and you are not holding it down here at the bottom. When you put your dry ice in this beaker, if you are carrying it from the bottom, that dry ice is so cold, it can, again, damage your skin if you're carrying it from the bottom. So today, when you are moving around the room with your beaker, you are only carrying it from this top rim, okay? Please make sure you are avoiding touching the bottom where that dry ice is in direct contact with the glass. All right, so next thing here, we're going to place that beaker with our dry ice back on that digital scale, and it will stay on our scale now for the rest of this experiment. The only thing is with these digital scales we have, the battery operated ones, they do turn off after a couple of minutes. So you are going to have to pick up and place your beaker down every minute just to make sure your scale doesn't turn off, okay? So you'll have, when you have your dry ice in there, again, you'll have some sort of mass that will register here. Every minute you're just going to pick it up and put it back down just so the scale knows that something is still happening on it and it should not turn off. That is the only downside with these battery operated scales. They're really nice otherwise. In your booklet that you get tomorrow, I do actually have little notes for you so you remember to do this. So every minute I have a note, pick up and put your beaker back down just to keep your scale turned on so you don't forget to do that, okay? All right, next thing here, we are going to have one of you head on over to our sinks and measure 100 milliliters of hot water, okay? Turn that left-hand tap, let it run until it is hot. This will make that reaction take place a little bit quicker. So 100 milliliters of hot water using your graduated cylinder. So you are going to be moving around the room with this. Again, the beaker is not leaving your scale from now on except to be picked up and placed back down just to keep your scale on. So we're moving around the room with your graduated cylinder. Get your 100 milliliters. 100 is this top line up here. Okay, so filling up to the top here with hot water and then bringing it back to your station. We are going to set that stopwatch to start counting up from 0 here next. So let's talk about our stopwatches. Okay, again, when you pull it out, hopefully it is off. So you just have to flick this little black switch on the side to turn it on. I'm going to have you for this lab just hitting the start button and let it count up from 0. Okay, don't hit it yet. If you already hit it, just hit the stop button. To clear, you hit both of these buttons at the same time. It'll get you back to 0. Okay, we don't want to hit the start button until you are 100% ready to go. Okay, but you have it all set up now, ready to go. We're going to be recording our data every 30 seconds. And again, make sure you have your stopwatch set up right here, ready to go. So you're ready to press that button and your goggles on before you move on to the next step. Okay, please make sure you have your goggles on. You can have some things popping and splashing out of your beakers, so please make sure you have those eyes covered and you're keeping them protected. Okay, once you have your goggles on and your stopwatch is set up so it looks like this and you're ready to rock and roll, the next step, step 7, you will pour your water from this graduated cylinder here into your glass beaker and immediately go ahead and record what the mass is on your digital scale. So once you have poured your water in here, immediately take a look at what your mass is down on your blue screen, and you are going to record that on your data table. So let's go ahead. I'm going to move that data table under for just a second here, move some stuff around. Okay, so that is going to be in our time 0. Okay, that very first one, right when you mix that hot water into your dry ice, you are going to put down what was that starting mass. And you are also going to be recording qualitative observations as we go through this lab. Okay, a quick refresher on qualitative versus quantitative. Again, remember qualitative, we see that word QUAL. Those are our qualities. Okay, so describing qualities or characteristics that you notice. So what does it look like? What do you hear? What do you see going on inside your beaker? That is what you are going to be describing over in this column. Okay, so your mass, as soon as you put that water in with your dry ice, record that initial mass right here next to time 0 and record what it looks like immediately. And then every 30 seconds, it's recorded as 0.5 of a minute here, but every 30 seconds, you will continue to be recording the new mass and what you are seeing going on in your beaker. Okay, again, describing those characteristics, what you see, what you hear. You might smell some stuff, but seeing and hearing are probably the two big things that you're going to be, the two big senses you'll be using. Okay, let's go back to my procedure. All right. So we are collecting data again every 30 seconds. Again, in your data table, you'll see it set up as a half minute, a minute, 1.5 minutes, 2 minutes. That's every 30 seconds for a total of 7 minutes or until your dry ice runs out. Okay, some of you guys might have your dry ice disappear before that 7 minutes is up. If your dry ice disappears completely, you are done. Okay, and you can start moving into your step 9. So when you get to step 9, actually you guys all can be working on step 9 as we're going through this. You guys can start setting up your graph and starting to look over those analysis questions in the downtime. I know every 30 seconds you're not going to have a ton of downtime, but if you do have some time, you can start looking at what is going to be your independent and your dependent variable in this situation. You can start setting up the scale on your graph for your independent variable. You can't set it up for your dependent variable yet, but you can start setting up for your independent. And again, start looking over those analysis questions. You can start tackling those if you have any downtime. Then when your 7 minutes are up, you guys are just dumping the contents of your beaker down the sink. This is a really easy lab tear down for you, lab cleanup. Again, please make sure you are continuing to carry that beaker from up at the top rim. You do not have your hand in contact with where that dry ice is directly in contact with the glass. Returning that bin to your teacher, return to your seat, and continue working on your graph and analysis questions. Okay, so this is a pretty easy lab to kind of get through here. If all goes well, you should have the majority of this data table filled in. Okay, not many of you guys should have that dry ice disappear before that 7 minutes is up. If you still have dry ice at the end of 7 minutes, that is okay. We're just going to stop at 7. Okay. Again, graph, you'll be setting up your graph here on the next page. Use your graphing checklist. It should be somewhere early in your notebooks. Your teachers will probably tell you on lab day what page this is at, so you can go back and review or go ask your teacher or look in your table of contents. Okay, but you're going to be setting up a beautiful graph, remembering those big 5 things that you have to have on every single graph. So you include everything that you need. And analysis questions on the back page here. Okay, again, coming back to this law of conservation of mass. What did you notice in this lab? Did this follow the law of conservation of mass? This question number 4 is going to be one of the more important ones. What could you have done differently? How could you kind of have designed this lab in order to get data that would have supported this law of conservation of mass? So I want you kind of thinking through, this is really going to show me the depth of your understanding here. Okay, that is really our lab in a nutshell. I hope you guys have fun with this on lab day. Ask your teacher any questions that you have, and good luck.